well, 69 square root of x. Implement int square root of x. Compute and return the square root of x, where x is guaranteed to be a non-negative integer. Okay, since the return type is an integer, the decimal digits are truncated and only the integer part of the result is returned. Okay. That would do it in oh yeah, that's true. Thanks for that. I definitely need to be better on for comprehension. I did it in some other problems earlier, but it's still not innate to me, especially when it comes to map hash table stuff. Also, I'm curious about your thoughts on Python 3.8 that just came out. So I'm very excited about it, kind of, but I haven't really used it yet, and all my stuff isn't updated to it yet. So, okay, cool. Okay, let me get back to this problem real quick, which is, yeah, implement. Okay. I mean, this is seems like a straightforward problem, right? It's just binary search. Um, X is a non-negative number. I think what I would even do is, well, I guess in Python it doesn't really matter, but and I assume we can't just call the square root function because that really kills the point of this problem altogether. But otherwise, you just binary search. Yeah. Something smaller. That should be okay. I worry a little bit about. These should converge, but okay. Actually, maybe I shouldn't do something sensitive. Maybe I just do something like just do it for 60 loops. I would also say if this was in any other language, not Python, I would double check how you write this just for overflows, because in theory these could overflow, and then, well, then you have an overflow problem. But yeah. Also, this would definitely overflow, possibly. It mid-type then has to be bigger, so head is going to. Ooh, why is that? That's fun. Yeah, let's find out the double representation. But maybe for real square roots is a little. There might be some like random rounding things. Instead of that, I'm just really wrong. uh, oh, okay. I think I just didn't convert these to doubles. That's why it's a little awkward. Okay, there we go. Maybe. Well, almost. Because why is this int 2.0 is there's something nuanced about Python that maybe I don't know. Oh, Python 4. Nav.4. And then I converted to int. Maybe that's better. Really? I mean, that's why this is wrong, but this looks so good. Sometimes he's a little annoying, but add some epsilon. I think maybe if I had done equal, maybe that's a little bit better. But let's see. Just for science, I mean, I actually would have been okay with what it was, but maybe that's the reason. what is like a big, maybe this is actually a little bit scary of an epsilon if the numbers get big enough, but okay. Let me try some additional number, non-negative, and then 2 to the 31. Oh no. Well, and I think this just overflows ends, so that's fair. Okay, I just submitted them. Oh no. These things. That's always the tricky thing with this. Maybe now that I change it right, I don't need this to be double. No, it is annoying. This double thing. I guess I still need epsilon. How do I feel about it? I don't really feel that well about it. Maybe I should have kept it in int. Yeah, I mean, then I could do that trick where I think one trick that I usually use, which is very surprising that I didn't do it here, is that I do something like, though I don't know how you would explain on the interview. I do something like, while head plus 10 is less than tail or something like that. And then you get some answer that head, whether this is true, where head plus 10 is less than tail. So then you just do a for loop of for x from head to tail, and then you just check if x times x is greater than, I overloaded it, is greater than x, then you return a minus 1 or something like that. Maybe I should have done it that way. But this is a very standard bisection problem, which is why I did it this way. But I don't know how I feel about it. A lot of negatives. But I think this problem would also be easier if, yeah, I mean that's what I could have done it with discrete a little bit. But I think it's also one of those things where you're always going to run into some issue. I mean, and this is not like ironclad, to be honest. Definitely for big outputs, or maybe even a different set of outputs, it may lead to a false positive, which makes this problem a little tricky. I think in general, the way I've seen this problem phrased is just return the double or the float, which is, this which is close enough. And I think I just skipped over that part as a result. But yeah, I mean, I don't know. Yeah, so this is bisection. So also like a really standard way of doing it, or like a thing that people have taught people. I don't know the way I would, the way I did it, maybe not. But yeah. Yeah. Well, the epsilon is just for is to fudge like this thing being like a little weird, because this always going to lean maybe a little bit toward the beginning due to truncation of even like the least significant digits, even on yeah, because even if you use, if this is for, maybe I should have been explicit about doubles. But because if this is like 32-bit float, then you actually even have fewer digits than like ints, right? To kind of play around with, and therefore you were gonna want to do things. But I don't know. Yeah. I mean, I definitely could see this as an individual version, but maybe with double and or float as the return value, therefore making things relatively straightforward. I feel like if you see this from an interview, you're not gonna get like tricky on the, or like I hope not anyway. In general, the unless maybe you're doing something specific to like I don't know what you might call it, embed systems or something direct like that. Like I think you don't generally need to know how like the IE standard works and stuff, other than a general idea of how double and folds work. Um, but I don't know. Yeah, yeah, okay. But yeah, but that's how I would phrase it. Look at your solution. Yeah, yeah, I mean, yeah, that's how I generally do it actually. Uh, Give or take. But yeah, I mean, yeah, definitely cleaner than what I did. But